Good morning to all. Today we can discuss about the factors about affecting the bandwidth of the oscillocoupled amplifier. So, as you all know, this transistor is used as an amplifier to obtain a high signal from a low signal quantity. The amplifier has to be designed in such a way it can amplify the signal and produce the output by varying the input applied to it. So, an RC coupled amplifier is a type of electronic amplifier that uses a resistor capacitor network to couple the output of one stage of amplification to the input of the next stage. So the capacitor blocks any DC voltage while allowing the AC signals to pass through. So the factors affecting the bandwidth of a RC coupled amplifier are mainly the coupling capacitors C1 and C2, the bypass capacitor CE, internal capacitance of the BJT or FET. So these resistor and capacitor values are carefully selected to optimize the frequency response of the amplifier. So this configuration is commonly used in audio amplifiers due to its simpleness with the proper consideration of this capacitor design. Okay. So first is the effect of coupling capacitor. So the coupling capacitors are used at the input side and the output side. So the capacitors C1 and C2 are the coupling capacitors used for blocking the DC port and allowing only the AC part of the signal to pass through. So the reactance of the capacitance is given by HC is equal to 1 by 2 pi FC. So this uh, the loading effect can be minimized by using this coupling capacitor. So this particular coupling capacitor, the AC, that is the reactance will be increasing with decreasing because both are inversely proportional and the AC is decreasing with increasing in frequency. So at low frequencies, the reactance of coupling capacitors will be large. So due to this, the voltage drop across them increases with the reduction in frequency. This increased voltage drop will reduce both the output voltage and gain of the amplifier in the low frequency region of the frequency response. Due to the nonlinear properties of the transistor, there will be some vulnerable to get this. You have to use the suitable load resistor and coupling capacitor. Usually, this is the reason for using the coupling capacitor. But because of this, in the reactance, the voltage drop across them will reduce both the output voltage and gain of the amplifier in the low frequency region. So it will be going to affect only in the low frequency region, not in the mid or high frequency region. Next is the bypass capacitor. So the bypass capacitor, it is actually placed across the emitter terminal. So this bypass capacitor will be used in this used across this resistance or E. So at low frequencies, as you know, it is going to be having some finite value. Thus the parallel combination along with RE and CE only going to offer the finite impedance. So this RE is not properly bypassed. So at medium and high frequencies, the bypass capacitor CE offers a very low reactance. So coupling capacitor is going to affect only in the low frequency and the bypass capacitor is going to affect in the medium and high frequency. So it can be replaced by a short circuit. So short circuit across this, we are going to use a short circuit means so that the short circuit gain we are going to calculate, right? So that will be, we're going to change your frequency. Next is effect of internal transistor capacitance. So there will be some internal capacitance across the transistor. So the coupling at high frequencies, the coupling and bypass capacitors act as a short circuit due to their low reactance and do not affect the amplifier response. But the internal junction capacitance are between the terminals, base emitter and the base collector and the collector emitter. There are three internal junction capacitance, which also going to reduce the amplifier gain and introduce unwanted phase shift as the signal frequency is increased. So this, if it is a FET, you can see CGD and CGS are the internal capacitance, and if it is a VGT, is a CBC and CBE are the internal capacitance. So this be across the junction, that is the across the input side and the other terminal. So base from the because base is the input for the common emitter. So it is base collector and base emitter. And gate is the input for the FET. So it is between the gate drain and gate uh, source. So these are the things which will be going to affect this RC coupled amplifier. But this what is the major use of this RC coupled amplifier is because it is going to give a very excellent frequency response. But it is going to be affected by these three parameters like the capacitor and going to reduce your low voltage and the power gain. Also, some noise will be produced and the impedance matching between the input and the output side is also going to be reduced. So these are the disadvantages of having this affected values. Thank you.